the total internal reflection. Let us understand the meaning of the concept and under what condition is the total internal reflection is effective, and this concept is vital in modern technology. Let us understand its application in the next session. Let us have a discussion on the internal reflection. Generally, there are two media 1, media 2. In this case, the medium 1 is denser, medium 2 is rarer, and the ray of light is passing from the denser to the rarer medium. While doing so, this is called an incident ray, this is a refracted ray. The refracted ray deviate away from the normal. This is angular deviation. Overall, this is angle of refraction, this is angle of incidence. Your angle of incidence in the denser medium, angle of refraction in the rarer medium. This is what the usual phenomenon. Let us go little more detail into this concept. Here, upon increasing the angle of incidence, what would be the angle of refraction? Let us increase the angle of incidence. This angle of refraction also increases. What is the alignment of the light ray? As the light ray is bending away from the normal, that is increasing angle of I towards the interface, and it is bent away from the normal in this direction towards the interface. As it is bending towards the interface, it is bending towards the interface like this. Upon increasing this, it also increases. And at one particular angle of incidence, increase. At one particular angle of incidence, the refracted ray grazes the interface of the two medium. It is passing along the surface, and the angle of refraction, that is angle between the normal and the refracted ray, are exactly equals to 90 degree. If that is the case, this angle of incidence, it is named as critical angle. At this condition, the I is known as C, angle of incidence. That angle of incidence is called as critical angle of a pair of media. And this is highly specific for a material, any a pair of media. And this is what the meaning of critical angle. Let us go further into that. Any further increase in the angle of incidence, when the ray of light is bending more and more towards this, what would be the ray of refracted ray? It is bending toward this. So while it is moving this side, this is moving in this direction. So it is bending back into the denser medium. So ray of light bounces back to the same medium. Condition when the angle of incidence is more than critical angle. All the incident ray at the interface, they bounces back to the same medium, denser medium, when the angle is more than the critical angle. This is similar to the reflection. Look at that. This is an incident ray, this is a refracted ray, of course, but it looks very exactly like reflection at the plane surface. So now it becomes angle of incidence, angle of reflection. So it is a incident ray, is a reflected ray inside the denser medium. So it happens in the denser medium condition when the angle of incidence is more than the critical angle. This is known as total internal reflection. Total internal reflection. Let us apply the law, that is Snell's law, for this refraction of, because it is a refraction of light, we have to apply the law. The law is applicable for refraction of light. Let us apply this. The law is sine of angle of incidence divided by sine of angle of refraction, the ratio. It is equal to ratio of refractive indices. Medium 2, medium 1. Medium 2 is this, medium 1 is. Is a rarer medium, it is denser medium. That is the one for all kind of refraction here. Let us look at this equation. What would be the alpha equation at this condition? What is the condition? That is when R equals 90 degree, I equals C. Under this condition, when R equals 90 degree, then I equals C. I equals means critical angle. Substitute and see that sin C divided by sin 90. Sin 90 is 1. Denominator becomes 1. Sin C equals n2 by n1. And one more concept. Among these two media, let the rarer media be air. Air is the medium. The refractive index of the air is almost equal to 1. And let us call this N1 is the refractive index of the denser medium, the first medium. Maybe anything, maybe water, liquid or solid, anything like that, or air. Medium 1, refractive index of the denser medium, N. Let us call this as N1 as N. N is called as refractive index of the denser medium. Then the equation finally becomes sin C equals 1 by N. N2 equals 1. It is a media, a pair of media involving air as one of the medium, rare medium. This equation is very important. The relationship is very important for the total internal reflection. If the angle of incidence exceeds this value, undergo, that is the internal reflection like this. It is related to refractive index of the denser medium and critical angle. These two are inversely related, inverse relationship. If the refractive index increases, sin C value decreases. See that mathematicals. Any increase in value of n will decrease the value of sin C. Any decrease in the value of sin C will decrease the value of C in turn. It means critical angle is inversely proportional to refractive index of the denser medium. Higher the refractive index of the denser medium, lower is the critical angle. Higher the refractive index of the denser medium, lower is the critical angle. If any material having very high refractive index, we can observe this kind of total internal reflection. Any denser medium, maybe a solid or liquid, any high value of refractive index produces lower critical value. If the critical angle is lower, internal refractions are predominates over this. So that is what the concept will explain. So this concept, I mean, very high refractive index or low critical value will explain the reason in nature. So that is what the equation says. Not only this concept we are using in modern technology to improve human life. For the improvement to human life, we are using this technology. Let us understand in detail in the next class, in the next session, what would be the phenomenal observations, that is remarkable phenomenal observations in nature that could be explained using internal reflection, and the concept we are using in modern technology. It is both in telecommunication and also in medical field finds extensive use of this concept. Let us understand that in the next class. Thank you very much.